Mm. Hello, hello, hello. Like this, like this. Mm. Hello, hello, hello. Like this, like this. Hello. I think the sound is okay now. So, sorry, sir. Uh, okay. So, it, let's continue where we stopped yesterday. Okay, we completed 8% of the foundation. Uh, okay. So, let's continue where we stopped yesterday. We completed 8% of the foundation. Hey guys, let me share the live link to someone. Wait, guys. Oh, 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 oh. Okay, let's start this. Okay, so this session contains a general overview of topics that you will learn in this lesson. Describe what is internet, describe what packets are, how they are used to transfer data. Wait, guys, let me check my sound. Okay, okay, okay. All is good, all is good. So, understand the difference between those page. Mm, 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 mm. Uh, Kirkun, welcome to the stream. So you are the guy who messaged me on the Discord. Wait. Okay, let's go. Uh, briefly explain what the client is. Briefly explain what the server is. Explain what the IP address now. Explain what is DNS server. Okay.
We are millionaires. We send 682 million tweets. We post 67 million. 4.4 billion used. 2.5 exabytes, 2.5 million terabytes of 2.5 data every single day. A significant proportion is giving of computers. The big one happens 50 years ago this week.
The American Defense Department, specifically the Defense Advanced Research Projects, they decided that it needed to connect about a dozen university computer systems together in order to promote sharing of information and acceleration of research and artificial intelligence. And so they promoted the design and development of a packet switch network, which they called ARPANET.
On October the 29th, 1969, at 10:30 in the evening, the message was sent over ARPANET. A computer at the University of California in Los Angeles sent a word to Stanford Research Institute in San Francisco. The word was login, although the system crashed before they got to the G. Nevertheless, those two nodes became hundreds and then thousands and then millions of connections. A global network of networks now consists of over 1.2 million kilometers of submarine cables, sometimes laid as deep as Mount Everest is high. These connect massive server buildings, and immeasurably more smaller cables connect those to individual computers.
Okay, guys, I'm not playing YouTube videos anymore because there are chances to get copyright issue. So I'm skipping that assignment. Okay, you can go read this Mozilla article. How does the internet work? what the internet is and how it works. Summary. Now, article first. The internet is a backbone of the web. The technical infrastructure that makes the web possible at its most basic. The internet is a large network of computers which communicate all together. The history of the internet is somewhat obscure. It began in 1960s as a US Army funded research project, then involved into a public infrastructure in 1918. With the support of many public universities and public companies, the various technologies that support the internet have evolved over time, but the way it works hasn't changed that much. Internet is a way to connect computers all together and ensure that whatever happens, they find a way to stay connected. Videos about internet. How's the internet works in 5 minutes? A 5 minutes video to understand the basics of internet by Odin Project. How does the internet work? Detailed well visualized in 9 minutes video. Deeper dive. Okay. Simple work. When two computers need to communicate, you have to link them either physically, usually with an internet cable, or wirelessly, for example, Wi-Fi, Bluetooth system. All modern computers can sustain any of those connections. Note, for the rest of the article, we will only talk about physical cables, but network works the same. Okay, such a network is not limited to two computers. You can connect as many computers as you wish, but it gets complicated quickly. If you are trying to connect say 10 computers, you need 45 cables with 9 plugs per computer. Okay, like this. To solve this problem, each computer on a network is connected to a special tiny computer called the network switch or switch for so this switch has only one job, like a signaler at a railway station. It makes sure that messages sent for a given computer arrive only at their target destination computer. To send messages to computer B, computer A sends the messages to the switch, which is then forward the messages to the computer B. Computer B doesn't get messages intended for other computers, and none of the messages for computer B reach other computers on the local area network. Once we added a hey Sugan, welcome to the scene. Once we added a switch to the system, our network of 10 computers only requires 10 cables, a single plug for each computer and a switch with 10 plugs. Hey, welcome to the scene, bro. Welcome to the scene. A network of networks. So far, so good. But what about connecting hundreds, thousands, billions of computers? Of course, a single bit switch can't scale that far. But if you read carefully, we said that a switch is a computer like any other. So what keeps us from connecting two switches together? Nothing. So let's do that. Okay. You may imagine that we can connect switches together infinitely to form a network like this. Mm, in reality, this leads to many engineering problems. The more switches a packet has to go through, the longer it takes to reach its destination, and you can't have just a three switches because then a single switch failure may disconnect a large portion of devices. To solve this problem, we keep sorry, okay, we keep each local network as small as possible, and we connect these local network using a separate device called router. A router is a computer that know how to forward messages between networks. The router is like a post office. When a packet arrives, it reads the recipient address and forwards the packet to the right recipient directly without going through layers of relays. Such a network comes very close to when we call the internet. We just need the physical medium, that is cables, to connect all these routers. Luckily, such as infrastructures already existed prior to the internet, and that's the telephone network. To connect our internet to the telephone infrastructure, we need a special piece of equipment called a modem. This modem turns the information from our network into information manageable by the telephone infrastructure and vice versa. Note that the commercial router is your home is likely a combination of a switch, a router, and a modem all in one device. So we are connected to the telephone infrastructure. The next step is to send the messages from our network to the network we want to reach. To do that, we will connect our network to an internet service provider. An ISP is a company that manages some special routers that are all linked together and and can also access the ISP's router. So the message from our network is carried through the internet of ISP networks to the destination network. The internet consists of this whole infrastructure of network. Finding computer. If you want to send messages to a computer, you have to specify which one. Thus, any computer linked to a network, a unique address that identifies it called an IP address, where IP stands for Internet Protocol. It's an address made of a series of four numbers separated by dots. For example, that's perfectly fine for computer, but we humans being have a hard time remembering that sort of address. To make things easier, we can alias an IP address with a human readable name called a domain name. For example, at the time of writing, IP address can change. Google.com is the domain name of used on the top of the IP address. So using the domain name is the easiest way for us to reach a computer over the internet and the website. Web. As you might notice, when we browse the web with the web browser, we usually use the domain name to reach the website. Does that mean the internet and web are the same thing? It's not that simple as it is so. The internet is technical infrastructure which allows billions of computers to be connected all together. Am I on those computers, some computers could also can send messages intelligible to web browsers. The internet is an infrastructure, whereas the web is a service built on top of the infrastructure. It is worth noting there are several other services built on top of the internet, such as email and IRC. Internet and extranet. Internets are private networks that are restricted to members of a particular organization. That they are commonly used to provide a portal for members to securely access shared resources, collaborate, and communicate. For example, an organization internet might host pages for sharing department or team information shared, drives for managing key document, and file portal for performing business administration tasks, and collaborating tools like wikis, discussion boards, and managing systems. Extranet are very similar to internet, except they open all or part of a private network to allow sharing and collaborating with other organizations. They are typically used to safely and securely share information with clients and stakeholders who work closely with the business. Often their functions are similar to those provided by an internet information and file sharing, collaboration tools, discussion boards, etc. Both internets are extranets run on the same kind of infrastructure as the internet and use the same protocols. They can therefore be accessed by authorized members from different physical locations. Company. Suppose. Okay, let's continue. Okay, watch this. How the internet works in 5 minutes. Wait, guys. Let me turn off the screen because it may be chance to get copyright on this layer. So I need to turn off the screen. Let me just okay.
So, how does the internet work? Most of us know how to use the internet without actually understanding how it works, sort of like electricity in your home. You use it every day, but may not understand the mechanics behind it. And if the electric grid is difficult to understand, then the internet must be impossible, right? Wrong. In the next few minutes, I'll put you in the top 10% of people who understand how the internet actually works. For SecurityCatalyst.com, I'm Aaron Titus. Whenever most people think of the internet, this is what comes to mind. The internet is not a bubble cloud, even in the new age of cloud computing.
Okay, and this, okay, if we check this video in the pending course, now let's read and study the topics. After I finish, stop this live, then I will watch this for sure. Okay, so let's continue the theory. Okay, read up on the difference between a web page, a web server, and a search engine. By this point in the module, you should have multiple modern web browsers installed on your computer or other available devices. This article goes deeper into using browsers, looking at how a web browser works, the difference between some of the everything you will interact with, and how to search for information. If you don't have any browser installed beyond the default ones that came with your devices, install some others. See modern web browser for more information. Okay, wait, let me check how much long is it. Oh, it's too long. Still, yeah, we can continue. Okay, uh, as as with any area of knowledge, the web comes with a lot of jargon and technical terminology. Don't worry, we won't overwhelm you with all of upfront. Mm, you can check the glossary if you are curious. However, there are some basic terms you need to understand from the beginning since you will hear these expressions all the time. We introduce some important terms below. Okay, learning outcomes. The difference between a web browser, a website, and search engine. How a web browser works at the basic level, searching for information. Okay, difference between web browser. Okay. We will start by describing various web-related concepts: web page, website, web server, and search engines. These terms are often confused by newcomers to the web or are incorrectly used. Let's make sure you know what they each mean. Let's start with some definitions. Web page, a document that can be displayed in a web browser. These are also often called just pages. Such documents are written in HTML language, which we look at in more detail later on. Website, a collection of web pages grouped together into a single resource with links connecting them together, often a site. Web server, a computer that hosts a website on the internet. Okay, web server, a computer that hosts a website on the internet. Okay, web server service, a software that responds to requests or the internet to perform a function or provide data. A web service is typically hacked by web server and may provide web pages for users to interact with. Many websites are also web services, though some websites, such as MDN, consist of static content only. Example of web service would be something that resizes images or provide a weather report or handle user login. Search engine, a web service that helps you find other web pages such as Google, Bing, Yahoo, DuckDuckGo. Search engines are normally accessed through a web browser. For example, you can perform search engines such as directly in the address bar of Firefox, Chrome, etc., or through a web page, for example, bing.com. Let's look at an analogy, a public library. If that is what you would generally do when visiting a library, find a search index and look for the title of the book you want. Make a note of the catalog, number of the book. Go to the particular section containing books. Find the right catalog number and get the book. Let's compare a public library with the web. The library is like a web server. It has several sections, which is similar to a web server hosting multiple websites. These are different sections, science, math, history, etc. in the library are like websites. Each section is like a unique website. Two sections do not contain the same book. The book keys each section are like web pages. One website may have several web pages. For example, the science section, the website will have books on heat, sound, thermodynamics, human biology, etc. The search index, like the search engine, each book has its own unique location in the library. Books, two books cannot be kept at the same place, which is specified by the catalog number. Let's now take the time to look at each term in a little bit more detail. Web page. A web page is a simple document displayed by a browser. A web browser can embed a variety of different types of resources such as style information, controlling a page, look and feel, script, which add interactive to the page, media, the image, sound, and videos. Okay, all web pages can each be found at a unique location. Mm, Web address, also called URL, to access pages. Just type its address in your browser address bar. Then try loading one of your favorite websites in the browser now. Bear in mind what we said above. Did you type in the web address yourself, or did you find it using a search engine? Website. A website is a collection of linked pages plus their associated resources that share a unique domain. Each web pages of a given website provides explicit links, most of the time in the form of clickable portions of text that allow the user to move from one page to the website to another. When you load your favorite website in a browser, it tends to first display the website main web page or home page, casually referred to as home. Try clicking some menu items or links to look at some different pages on your favorite website. Note how the displayed web address will come Yes, I'm back. I'm back. I'm back. Yeah. Try again. Note, it is also possible to have a single page app, a website that consists of a single web page that is dynamically updated with the new content when needed. If this is the case, the web address might not change as different pages are viewed. Web server. A web server is a computer hosting one or more websites. Hosting means that all the web pages and their associated files are available on that computer. The web server will send the page files it is hosting to a user's browser that when they attempt to load it, don't confuse websites and web servers. For example, if you hear someone say, "My website is not responding," it probably means that the web server is not responding and therefore the website is not available. Okay. More importantly, since a web server can host multiple websites, the term web server is no longer used to designate a website, as it could cause confusion. If someone says my web server is what? Okay. If someone says my web server is not responding, to me that multiple websites or applications hosted on the web server are not available. Search engine. It's common for people to mix up search engines with websites. A search engine is a special kind of web service that helps to find pages and they are interested in, as well as specific types of content such as images, videos, or news articles. Search engines all tend to have their own website that can be used to access the underlying web service. There are plenty out there. Google, Bing, Yandex, DuckDuckGo, and many more. Some are generic, some are specialized around certain topics. Many beginners on the web confuse search engines and browsers. Let's make it clear. A browser is a piece of software that retrieves and displays web pages. A search engine is a web service and usually a website that helps people find web pages content on other websites. The confusion arises because the first time someone launches a browser, the browser often displays a search engine website homepage or a search box, allowing them to search for a term using the search engine. Most browsers also allow their users to use the search engine by typing search terms directly into browser's address bar. This also makes sense because the first thing people tend to want to do with a browser is find their web page to display. Don't confuse the software with the service. Here is an instance of Firefox showing Google search box on its default setup page. Try using a search engine to find information on subjects where you interested in going to search engine homepage, entering search term, entering a search term into browser address bar. How the web works, the basics. In many parts of the world, the web has become just an essential a tool to our everyday lives as cultural grocery, bicycles and cars or toothbrushes. If that sounds unrealistic to you, just think about how often you use a website or mobile phone app each day. Even if you are not typing a web address to a web browser to access content or services, the changes are that half of you making is probably using web technology behind the scenes to grab data to present to you. When you access a web, quite a lot happens between your first interaction. For example, typing a web address URL into a browser and pressing enter return and the result of your action being presented to you. For example, the website appearing in your web browser. The web browser requests the resources, for example, such as get it described what should happen. Okay, we are back now. Okay, yes, okay. There's not much, so let's do this quickly. If the request is successful, the web server sends a HTTP response back to the web browser containing the request resources. In some cases, the requested source will then fire off more HTTP requests, which will result the more responses. For example, a website is loaded. Initially, the main index HTML file of the site homepage is requested. When that file is received by the browser, it will start to press it and will probably find instructions to make more requests. As discussion about these might be for files to embed, such as images, files, information slipped, and so on. When all of the resources have been requested, the web browser uh, processes and renders them as required before displaying the result to the user. This description of how the web works is heavily simplified, but it is all you really need to know. At this point, you will find a more detailed account of how web pages are requested and rendered by a web browser in our web stand module slightly later on. Searching for information. Okay, as a web developer, you will spend a lot of time searching for information from syntax you can't remember to solutions to specific problems. It is therefore a good idea to learn how to effectively search the web. If you know a website that relates in the subject you are learning uh, about, it is often a good idea to start there. For example, uh, looking for if you are looking for general information about specific web technology features, you should type the name of the feature into the NDM search box. For example, trying to type in box model, pet, or video element in the search box and see what comes up. If you don't find the information you need, expand your search. Try your search items in a search engine. If you are searching for a solution to a specific problem, such as how to print out the Fibonacci what Fibonacci JavaScript sequence with JavaScript, or how to calculate whether a number is a prime number with JavaScript, it is it is a good idea to search on a website such as Stack Overflow. Which is a community dedicated to answering programming problems. Again, try using a general search engine if a specific site doesn't give you a helpful answer. Before you move on, try searching for some topics of your own that you would like to learn about. Try using more and less specific searches and different related terms to terms to see what works best. See our search tips for more things to try. AI generated searching results are a very popular way to receive information. They basically provide us a super search. They do a lot of searching in the background before comparing the results in a single, easily digestible answer. Common choices are ChatGPT, Google Gemini, and Microsoft Copilot, accessed either directly in a chat form or via AI-powered in-app helps or automation system. When learning to code, AI chat forms can be useful in a variety of ways. Doing conventional searches like example above, figuring out bugs in a block of code. If you are getting frustrated because your code is not working, you can paste your code into an AI chat prompt preceded by a question such as where is the mistake is in this, this code, generating an optimized version of specific block code. This can be useful when you have written a block of code that works, but you want to find out how it could be done more efficiently or in a more robust a way that resolve more use cases, providing advice on how to do something. For example, if you don't just want to know where the bug is in a block of code, but instead you want advice on what strategy to use to debug it, try using a couple of AI tools to do some searches, a cautionary tale. Yeah, that's just a little bit. Okay, AI can do so much that you may start to wonder why you need to learn to code. But wait, the following is important. You still need to understand what are trying to do at a high level, what the code is doing, and where each piece of code needs to be used. If you don't, you won't be very useful when trying to solve real world problems. These problems that you still need to learn to code, AI can be a really useful tool to help you find answers more quickly. But if you just type every question you are asked into AI prompt, you won't understand how anything works. In addition, AI tools uh, present their answers in a confident or voice, but they can often be misleading or just plain wrong. Some of the mistakes they make can be very subtle. They don't have any innate intelligence of their own. They are basically advanced pattern matching tools. AI tools compare their answers for other sources or out there, so will hover up wrong information as well as correct information. Even two correct sources can be combined to get an answer that is incorrect. Newer information may not be available or answers may be skewed to older and more prevalent documentation. So how to do X in JS might give you outdated guidance. As a result, you need to be careful to check the answer they give you and just try trust everything without question. When you are learning, spend time trying to solve the problems yourself before searching for an answer. Whether you are using AI or conventional search engine, it will make you a better developer. Search tips. Last topic. Search tips. You should include the language you are using in the search term as shown in the example above. If you just type in how to print out the Fibonacci sequence. I don't know how to pronounce this word. Okay. Fibonacci sequence. I don't know what the hell is that. Okay. Uh, that sequence you would likely end up several solutions in Python, C++, Java, Ruby, or other languages. Not very helpful when you are trying to learn JavaScript. Uh, when you find a useful answer, bookmark or make a copy of it somewhere so you can find it again later. You will be amazed how many times you run into the same problem. If your code is returning a specific error message, try entering the error into a search engine or AI prompt. Other people will probably have already tackled the same errors in the past and recorded solution publicly somewhere. If possibly, stick with recommended sites like NDN and Stack Overflow. Okay. There are many advanced search techniques you can use in search engines that will give you better results than just typing a plain search term. Trying in a plain search term such as and fish will return results that contain any combination of those words. However, most search engines support variation of the following syntax patterns. Typing in and fish Chinese with quotes will only return results that contains that asset. Fish and cheese fish will uh, return results that contains and or cheese but not fish and or cheese. Will only return results with one term of the other, not both. From from our testing, this one only seems to work efficiently in Google. In title, cheese will only return results that have cheese in the main title of the page. Note: there are many other techniques you can use in various different search engines. Try seeing what you can find. Some useful resources are define Google searches, how to use other syntax on the Go search, and Microsoft Advanced Search option. Okay, I just feedback it. So now okay, I will watch it later.
The most important program on your computer is your web browser, and yet most people aren't sure which web browser they're
Then use this. Uh,
The most important program on your computer.
okay. So I am okay. I am going to end this live. Hey bro, hi bro, fine anime. Welcome to stream, but you are late today. I am going to end this live. Anyway, thanks for clicking my video. Science anime. Uh, thanks bro. So thanks for watching for all. So I am ending this live.